Number 48 is asking us to take the derivative of this messy function right here, which is a good example of why the product rule is really necessary, guys, because under no circumstances would a sane person want to take a binomial to the fourth power and expand it, then a binomial to the third power, expand that, and then multiply the two of them together. That would take you forever and a day just to rewrite y in another form. So we're going to go ahead and use the product rule right here. So we're taking the derivative of y with respect to z here. And here we go. First factor multiplied by the second factor. So to do our product rule, we take our first factor, which is z plus 1 to the fourth, times the derivative of the second. Here's where things get interesting. The derivative of a binomial to the third power, we begin by using the power rule there. It would be 3 times the same base of 2z minus 1, drop the power by 1, which is 2, and here comes the chain rule, times the derivative within, which is going to give us a times 2 at the end of all that. So that is first times derivative of the second. Plus, here we go now, continuing with the product rule, the second factor, 2z minus 1 to the third power, multiplied by the derivative of the first, which would be a 4 times a z plus 1 to the third power. And if I'm being consistent, I would need to do the same thing right now that I did right over here. Multiply now by the derivative within. However, this is kind of worth talking about, the derivative of z plus 1 is just 1. Technically, you can put the times 1 there. You probably should for consistency's sake. But this proves the interesting point, guys. You can get away with forgetting the chain rule if the derivative within happens to be 1. There's really no point in even thinking about it. However, you just have to be careful that you don't get into bad habits in doing that. Now, the calculus of this problem is done, but what happens next, I'll bet, is that a lot of you guys got here, and then you did one more step to try to simplify this, and then couldn't figure out why your answer looked so different from the book's answer, and I think I know why, but let's get into it. This is the step I bet you guys did fine at. Simplifying this first term, I see a 3 and a 2, so I'll put a 6 out in front, and then a z plus 1 to the fourth power times a 2z minus 1 to the second power. And then for the second term in the product rule right here, let's see, everything is positive, so that'll be a plus. The 4 times 1 is going to give me a 4. A 2z minus 1 to the third power, and then a z plus 1 also to the third. And as I said, I'll bet a lot of you guys quit right here. And if you were to quit right here on a quiz or a test question, you would definitely get the majority, the overwhelming majority of points on this. If I had to guess, this would probably be something like a 4-point problem on a quiz or a test. You'd get 3, or maybe 4 points out of 5 if you quit right here. But why wouldn't you get full credit? Because there's a little bit of work left to be done in a manner of simplification that you guys don't always think about, and that is factoring. You have 2 big terms here in your answer. There's term number 1 and there's term number 2. And all over the place, these 2 terms have common factors. So I'm going to utilize what is essentially the reverse distributive property, and I'm going to pull out all the common factors of these 2 terms. Let's start with their coefficients. 6 and 4, we can bring a 2 out in front. Here's where it gets fun. Z plus 1, we've got 4 of them here, 3 of them here. So I can pull out 3 Z plus 1 factors. Those get brought out in front. Then look at the 2Z minus 1s. 2 of them right here, 3 of them right here. So I can pull out 2 of them. 2Z minus 1 quantities squared. And all of that, you guys, is our greatest common factor. So we now then, let me put brackets right here. Now we have to think about what's left from these 2 terms here after we've factored out their greatest common factor. So here we go. The 6 divided by 2 gives me a 3 out in front. Z plus 1s, there were 4, we pulled out 3 of them. So there were 4, we pulled out 3 here. There you go. So that leaves 1 factor of Z plus 1. And here's where it gets interesting. That first term had 2 factors of 2z minus 1. We pulled both of them out in front, so there are none left. This is all that remains from this first term here when we did the product rule. Let's keep going now. Plus, now we move on into the second term. There was a 4. We pulled out a 2. That leaves us with a 2. we had three factors right there, 3 of 2z minus 1. We pulled out 2 of them. So that leaves 2z minus 1 behind. And then there were 3 factors of z plus 1. We pulled all 3 of those out. So there are no z plus 1s left. And that means, everybody, that what I have written right now is everything that's left. I guess I overshot how big that needed to be. That is everything we have left now of what's inside. And there is one more step I think we can do to clean this up just a little bit. All of this, guys, falls into the realm of reasonable simplification. There's the distributive property we're going to do here, and then we're going to combine some like terms. Now, this GCF is written in factored form. We're not going to do anything with that. So 2 times z plus 1 cubed times 2z minus 1 to the second power. And then, I don't even think I need brackets. I'll just go to straight parentheses right here. We've got a 3z plus a 4z. That's going to get us a 7z. And then for constants, I've got a plus 3 right there and a minus 2. So that'll be a plus 1. And guys, that's as good as this thing is going to get. Derivative of y with respect to z is equal to this expression right here. So number 48 is a great question. I'm glad you guys asked it, because you can do everything right, but if you want to match their answer in the back of the book, and if you want to get full credit for a fully simplified answer as much as is reasonable, we've got to take that time to factor what we can out of those 2 terms after using the product rule, and then try to simplify what was left over.